All right, 8.2b, analyzing arithmetic sequence and series. Part B. Okay, so we're going to be using this formula. Arithmetic series is formed by adding the terms of an arithmetic sequence. So this formula right here, the sum of the first n terms of the arithmetic series is this right here. This is the number of terms in the sequence. That right there is the value of the first term, and this is the value of the nth term, the last term in that sequence. And it's a 2. So here's going to practice here. This says right here, for the question number 37, in the book it says, write a rule for the nth term of the arithmetic sequence. Write a rule. Find a formula for this sequence. Okay, so this means the 8th term in the sequence has a value of 12. The 16th term in the sequence has a value of 22. So we're going to use this formula. Using that formula. The nth term, n is going to be, we'll start with this one, 8. 8 minus 1. We don't know what d is yet. All we have is, I'm going to write a formula using this. And then I'm going to write a second formula using that information. So, don't know what d is. I know 8 is n. N is 8. The 8th term has a value of 12. Value of 12. I don't know what the first value of the sequence is. So all we have is this. I'm going to write another formula using this information. Okay? When n is 16, n is 16. D, don't know what d is. We know when n is 16, the value is 22. When n is 16, that value is 22. 22. Don't know what the value of the first term is, though. So now we have this right here. This is 2 equations. 1 unknown, 2 unknown. I may see this more than once. I may see this more than once. But we have 2 equations and 2 unknowns. We have a system of equations we can solve. So I'm going to rewrite that. 12 equals a sub 1 plus 7d. 22 equals a sub 1 plus 15d. 2 equations, 2 unknowns. Let's solve this. Take the bottom equation minus the top. The bottom equation minus the top equation. 22 minus 12 is 10. This minus this is 0. 15d minus 7d is 8d. 8d equals 10d. Divide both sides by 8. 8. D equals 10 over 8 or 5 over 4. Boom. So that's what the value of d is, 5 over 4. So I'm going to rewrite this. I'll use this one. I don't know what. We now know what d is, so I'm going to take this equation. I could use either one. I'm going to pick this one because it's smaller numbers. 12 equals the value of the first term plus, when n is 8, we know that d has a value of 5 over 4. 5 over 4. So 12 equals a sub 1 plus 7 times 5 over 4. 12 equals a sub 1. 35 over 4. That's 12, 11. 12 equals a sub 1 plus 9, 8 and 3/4. 35 over 4 is the same as 8 3/4. Subtract 8 3/4 on both sides. And 8, 3, 3, 3 1/4. The first term has a value of 3 1/4. So take this equation. I don't know what a sub n is, but we know the value of the first term is 3 1/4 or 4, 12, 13 fourths plus n minus 1 times d. D is 5 over 4. We can now find the rule for the arithmetic sequence. You can find this rule. Find the formula for the nth term. 13 over 4 plus 5 fourths times n minus 5 fourths. These are like terms. 13 minus 8. 5 fourths n minus 8 over 4 equals 5 fourths n minus 2. Oh, beautiful. There we go. We have our first one. Wait a minute. That's going to be plus. So, when the 8th term has a value of 12 and the 16th term has a value of 22, what's the rule for this? What's the value of the nth term? What's the formula? There it is right there. 5 fourths times n plus 2. Done. Next problem, same thing. Same type of problem, except just different numbers. The 10th term has a value of negative 13. The 38th term has a value of negative 97. Find the rule for the nth term. Find a formula for the nth term of that sequence. So we're going to write this using this formula again. The negative 13. A sub 1 plus 1, n is 10. 10 minus 1 times d. Then I do it again. This same formula. Do it again using this information. The value of the 38th term is negative 97. So negative 97, that is the value of the first term, whatever that is. N is going to be 38. Times d. We have two equations, two unknowns. Two equations, two unknowns. Simplify this. Bring it over here. Negative 13 equals a sub 1 plus 9d. And negative 97 equals a sub 1 plus 37 times d. So we just, 10 minus 1 is 9, 38 minus 1 is 37. Two equations, two unknowns. I see a sub 1. I don't care if I see more than one, so that's just one unknown. That's the second unknown. Two equations, two unknowns, that can be solved. So when we subtract this, those are going to disappear. I'm going to take the larger value. This is the larger value minus the smaller value. This value is larger than that value. Keep in mind those are both negative. This minus this, 37 is 84. This minus a negative 97 gives us 84. This minus this is 0. 9 minus 37 is negative 28d. Now we have, divide both sides by negative 28 divided by negative 28. We get negative 3. D is a negative 3. The constant difference is a negative 3. D, common difference is negative 3. So I'm going to take this equation, I'm going to go back to one of these two equations. Take your pick. Hey, for me, I like working with numbers that are smaller because they're easier to work with. It looks like it's going to be this one. These numbers here are smaller than those numbers there. So take that equation. And instead of writing D, put a negative 3 in its place. Negative 3. Now, before we go on, times, make sure that's in parentheses. So negative 13 equals a sub 1. 9 times the negative 3 is a negative 27. Okay, that's a 9 times the negative 3 is negative 27. Add 27 on both sides of the equation. Mm-hmm. 14. The value of the first term is 14. The value of the first term is 14. So now we can go back to, let's go to this equation here. This equation right here. 14 plus n minus 1 times d. d is negative 3. Again, don't leave it like that. Right now it's a minus 3. It's supposed to be times. So this is going to give us our value of the nth term. 14 minus 3n plus 3 gives us 17 minus 3n, negative 3n plus 17. There's the value of the nth term in the sequence right there. Okay, so if the 10th term has a value of negative 13, if the 38th term has a value of negative 97 for an arithmetic sequence, what's the value of the nth term? There's our rule. There's our formula right there. Boom. Done. Next. Question 47. On question 47, find the sum. Find the sum given this information. Given this information, we will get a little closer. This information right here. So finding the sum. What? How do you find the sum? When did you ever tell us how to find the sum? Here's our notes right here. This is the sum of the first n terms. So this is the number of terms. That's the value of the first term. That's the value of the nth term. So this right here, summation notation, sigma. How many terms are there? Uppercase minus lowercase, 20 minus 1 plus 1. So that's going to be 20. So n is going to be 20. 20 terms. Okay. What's the value of the first term in the sequence? Well, when I is 1, 2 times 1 is 2, minus 3 is negative 1. So the value of the first term is negative 1. When n is 20, so the last term in the sequence, when n is 20, where I is 20, the value is going to be 20. So 2 times 20 is 40. 40 minus 3 is 37. There we go. The first term in the sequence has a value of negative 1. The 20th term in the sequence has a value of 37. In the sequence, the last term is 20. First term, value of the first term, value of the last term, 20 terms. Use the formula. 20 terms. Negative 1 plus 37 divided by 2. 36 divided by 2 is 18. 20 times 18. What's 20 times 18? 2, 18, 36, 30, 360. So if you took this and added up all these first term, second term, third term, fourth term, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20. All 20 terms, you add them up, you're going to get 360. Boom, there's your answer. Why add them all up when the faster way is to use the formula? Answer is 360. Okay. Another problem, last problem. Here we go. Here's a formula. And what we're going to do, find the sum of all these terms. This is summation notation, which means you're going to have to add them all. Why do I not want to add them all? Because there's a formula for that. It's right there. It's right there. Why do I not spend the time adding up all of those? I don't want to do that. I want to use why work harder when I could work smarter? Okay. N, how many terms are there? 81 minus 3 is 78 plus 179. There's going to be 79 terms. 79 terms in this case. The value of the first term and the value of, sorry, the value of the first term when k is 3. The value when k is the 79th term. First term when k is 3. Now keep in mind when you do this, it's not a 1. That's not a 1, it's a 3. The first term when k is 3, figure out what that is. 0.3 times 3 is 0.9 minus 2.8. Okay? 0.9 minus 2.8 is negative 1.9. The value of the first term is negative 1.9. The first term has a value. When k is 3, you get negative 1.9. 79th term is the last term. There's 79 terms. There's not 81 terms. There's 79. Okay? The last term, when k is 81. 0.3 times 81. Let me do that. 81 times 0.3. 24.3 minus 2.8. Is that 21.5? Yeah, 21.5. 21.5. Put it into this formula. How many terms are there? There's 79. 79 terms. The first term is the value of negative 1.9. The last term of the sequence is 21.5. Whoops. 21.5 divided by 2. And do it on a fancy gadget calculator. Negative 1.9 plus 21.5 equals divided by 2 times 79. Gives us 774.2. 774.2. Not units, it's just numbers adding them up. There's no units because there's no distance or length or anything, so it's just this. No units, no feet, no miles, no minutes, nothing. There. In this case, there are no units because they're just adding up these numbers. So if you added up all these for this summation notation, you could go through this 79 times and figure, why? Why do that? Why work harder when we can work smarter? Okay, use that right there. The answer would be 774.2. Boom, done. Sweet Aunt Jemima.